Now that moves us again away from the land, but into the arena of gene editing. And on Monday of this week, the Delegated Legislation Committee of the House of Commons debated the draft genetic technology regulations, the secondary legislation on what is described as precision breeding. And this follows the General Act of the same name of 2023. The Permanent Undersecretary, Emma Hardy, describes the draft as an enabling regulatory framework, which brings to mind the compromise and corruption of the MHRA, a connection which is more relevant than ever, considering that we're looking at altering the genetic makeup of organisms. DEFRA is trying to sell this as a technology which reduces costs to business and encourages innovation and investment in the development of precision-bred organisms. At the same time, it's insisting that the proposed regulatory approach will be more proportionate to risk, but it's not quite clear more proportionate than what. Unwilling to concede that there may be any downside to this technology, DEFRA goes on to suggest that gene editing could help to develop crops with improved nutritional value, resistance to disease, and resilience to climate change. Note the word could. To get a sense of where this is going, it's worth looking back at the progression of the narrative. And here's a video put out by the Royal Society 8 years ago.
First, let's look at the positives. Gene editing could make radical improvements to human health. For example, in 2015, doctors used genome editing techniques to cure a baby girl's leukemia. In the future, we may be able to fix the gene mutations that predispose some people to cancer, or enable new therapies for HIV, or edit the genes that cause hereditary diseases. In the plant world, it could make crops more nutritious, disease-resistant, and able to grow in difficult conditions. By editing animals' genes, we could help them resist diseases. Scientists are currently working to edit the genes of mosquitoes to prevent them from carrying malaria. So genome editing has enormous positive potential. But what about possible downsides? Genes could be edited in early human embryos to alter characteristics such as eye colour that have no bearing on health. This raises the possibility of designer babies. And changing an embryo's DNA would not only affect the child, but their descendants too. These same techniques could also be used to create designer pets or develop more virulent microbial diseases. So, alongside the many benefits of genome editing, there are also some ethical and societal concerns to consider. The technology is already in our hands. Now's the time to debate how we use it, regulate it, avoid negative uses, and unlock its potential to provide life-changing solutions to some of the world's biggest challenges.
There we go. It seems quite clear that the key message to be taken away is that if we improve our nutrition via improving the growing conditions of our plants and animals, we'll then be able to convert those benefits by tinkering around with our own genetic composition for the greater good. Of course, all of this is predicated on the assumption that the description of precision breeding is actually accurate. And as it stands, we're told that the results of gene editing may only contain genetic features that could have resulted from traditional breeding processes, and that the editing itself is just an acceleration of other processes. So even if taken at face value, the law of unintended consequences will have its part to play, and this means that nobody can possibly know the medium to long-term outcomes. What is barely ever referred to is the response of the environment to the precision-bred organism. The focus is always on the breeding technology and not on the consequences to the food chain either side of the organism in question. Now, the reason for making this point is that it's always stated as an absolute truth that gene editing should be regarded as completely separate from the modification of genetic organisms, in that GMO may introduce genetic material from unrelated species, but given the complete uncertainty over the outcomes and the constant use of conditional language such as could, this distinction is semantic rather more than legitimate. Anyway, back to Parliament. Emma Hardy attempted to brush off the work of the Secondary Legislation Scrutiny Committee of the House of Lords, which had written in late March that this is a, quote, complex and sensitive policy area about which there are strongly held views, and that concerns have been raised about the lack of labelling requirements, despite apparent strong consumer preferences for mandatory labelling of products containing precision-bred organisms, and the impact of the new regulatory approach on trade and on organic producers. End quote. This roughly translates as a deeply held suspicion by the public, both of the products themselves and the way in which the government may manipulate outcomes for consumer and producer alike. The other focus for the messaging on this debate is that the only reason animals are succumbing to the well-publicised diseases such as foot and mouth, blue tongue and bird flu is that the animals themselves are defective and in need of updating or upgrading. This has the twin effect of ignoring the conditions that they're kept in, as well as impregnating the public consciousness with the idea that eliminating disease via gene editing is something which could and should be applied to humans too. So I think we'll have more to discuss on this in Extra, especially the potential for any of this regulation to be weaponized in such a way that only gene-edited or cultured food is permissible, especially since all of this technology is currently banned in the European Union. And finally, of course, there is the question, which is almost never asked, what if things do not turn out well? How does DEFRA or anyone else reckon on stuffing the genie back in the lamp? Here a piece from the Health and Safety Executive about an accidental release for a GMO, admittedly significant and unintended release of GMO, and which presents an immediate or delayed risk to human health or the environment. Plenty to think about, and it deserves a great deal more scrutiny. Now, this takes us back to Vanessa.